Hello and welcome back. Today on the operating table we have this 2020 MacBook M1. This is the A2337 edition. Customer named Mike brought this in for repair and apparently we have no power on it. So let's take a look and see if we can fix it. Let's begin. So you guys know the very top circle here, that's going to be my multimeter. And then the one below it, that is going to be the power supply, or basically what the power is coming from the actual MacBook itself. All right. So the first thing we're going to do is we're going to plug it in and we're going to see what the symptoms are. So plugging it in right off the bat. And as you can see here, this is a weird one. We have 5 volts and then it's ramping up to like 8 there. I saw 13. What else we got here? 10. It's jumping all over the place. All right, so that's the top USB port. So let's try the bottom USB port and see if we have the same thing here. And we have 5 volts, 11 volts, 13 volts. So it looks like it's doing the same thing. So when you have both these ports doing the exact same thing, that kind of gives us an indication as to what's going on. So in this case, port number 1 up here was giving us 5 volts. It was jumping it up to 11 volts. Sometimes we saw 14, 15 or whatever. The bottom port was doing the identical same thing. So it lets us know that chances are it's not going to be the CD3217 chips here which control this port, because we actually saw it go and almost ramp up to PP bus voltages, which lets us know that the CD3217s are probably okay. It's getting the LDO voltages from the CD3217s. The ISL, in this case, it's a 9240 HI that's in here, is probably ramping up. But as soon as it hits the PP bus voltage rail, another thing is shutting it down. So something maybe on the PP bus rail or something that's a sub rail that's controlling it, that's causing it to crash. It could even be the PMIC. It could still be the CD3217s. It could just be a weird fault. So this is going to be an interesting one. So let's open up the MacBook and take a look and see what we find. All right, so we're under the microscope, and I'm just going to quickly just go through and make sure there's not something completely obvious. So we get a clearer picture there. There we go. There's something completely obvious that's going to save us a lot of time and pain. And I don't see nothing really obvious yet. But you're just looking for cracked capacitors, liquid damage, anything like that. And I don't see nothing here. So I'm just going to take out the board and flip it on the other side. All right, we are on the back of the board. And these are the 2 chips I was telling you about earlier. These are your 2 CD3217 chips. So when you first plug in your USB charger, if you put it on the top one, it's going to go to this chip. If you put it on the bottom one, it's going to go to this chip here. Like I said earlier, though, if you're pulling the same amp draw and getting the same voltage from both of these ports, chances of it being the CD3217 that's the fault kind of diminishes. Because that's one of the symptoms of a faulty CD3217 or a 15 chip, is you're going to get different voltages and different amp draw on the chips. Now, it doesn't mean that this is working, but it kind of, just from what I've seen so far, it does look like this is not the issue, because I do get my main power rail up just for a split second, which means this chip's working, and I'll show you in a bit. It means also that, where is it here? This chip right here is working. These are the 2 first chips that you really need up and running on your board before everything will start to fall into place, especially PP bus, right? Which we kind of briefly saw, but it wasn't fully there. So let's look around the rest of the board here and just see if there's something that sticks out. It'd be nice to just find a cracked capacitor or something, just make life so much easier, but that rarely happens for me. So we're just looking around the board here for anything that's cracked, damaged, liquid damage, even components that have been knocked off the board because you don't know if someone else has been in here. And this board looks like really clean. Yeah, there's not even dust on this board. And we have nothing that's glaringly obvious. Okay, so what I'm going to start doing then, I'm just going to just start poking around here. So I'm going to flip the board back over and I'm going to check my 5 volts, my 3.3, my PP bus. I'm just going to start with the major rails here and see if we have a short. We're going to start off with PP bus A on. It used to be, this is the M1, so it's no longer called PP bus G3 hot. They changed it to A on. It just means always on. We're going to check our 3.3, 1V8, 1V2. What else? I'm hoping there's a short on one of them. Makes life easier because then we can just do voltage injection and just have this board up and running. So let's switch over to the board view here. And let's see what we got here. So right off the bat, we could check PP bus A on right here. And I think right beside it, we got PP5V S2. And actually, we could check our LDO voltages coming from our CD chips while we're at it. Yeah, let's start by just poking around first and see what we got. I'm just going to be in diode mode. I like to use diode mode. I know a lot of people like to use resistance mode. It really doesn't matter which one you use. I mean, uh, if you have low, very, very low resistance, you know you got something going on. If you're in diode mode and you have low voltage drop, you know you got something going on. So it really doesn't matter what you use, but I like using diode mode. So let's just get this into focus here and into frame. And we'll first check this one here. PP bus A on right here. And as you can see at the very top there, we have 0.5 voltage drop. Now I'm not going to go back and check each one, but I'll just show you why it's nice to use the board view software. So if you go into the board view software where you could actually see that you're supposed to have 0.5 voltage drop. Okay, so it really helps you because if you didn't have this software, if you had, let's say, zero point 0.2 or zero point 0.1, right? Do you think, is it good or bad? You have no idea, right? So it's nice to go back. So I'm not going to go back to each one, um, but just to show you with the Paul Daniels software how nice it is to have that. So in this case, we don't have a short on PP bus. PP bus is okay. The next one we're going to check here, P5VS2, which is just right beside it. Okay, this is going to be right here. And checking that, 0.3, we're good there. All right, next one we're going to check is PP3V3A on, and that's going to be right here. And we're 0.5. All right, the next power rail is going to be PP1V8. I think it's A on, so let's just check here. And 0.49 voltage drop. All right, next one is going to be our NAN. And we don't want to short on this one for sure. Let's see. And we're 0.37, that's good. Okay, so I have gone through this entire board and I cannot find a short. And I was thinking that's what it was going to be because I mean, I got my PP bus that's kind of creeping up and going off sometime. It could still be a short, but what I've done for now is I've taken off the connection over the PMIC here. I'm going to check this area just to see if we have a short in this area. All right, so let's switch back to board view for a sec and look at what we have here so far. So far we got a MacBook that won't go into DFU mode. Both CD3217s are roughly the same amp draw. We have no shorts on the board that I can see. So I'm guessing either right now I'm gonna double check the LDO voltages coming out of the CD3217s, or I might actually just take a chance and just change my my ISL 9240HI right here. But before we do that, let's just quickly check for shortages on the LDO, which that's the only thing I forgot to do. I didn't check the LDO voltage of the CDs because I figured, you know what, they seem to be working fine, but let me just check for shorts there, and then I'm gonna put it under a thermal camera because so let's just check our LDO voltages here first and see if we have a short on here. All right, so we're still in our board view here, and we'll see right here we have our LDO for this CD3217. Let's see if we have a short there. I'm pretty sure we're not going to have anything going on there, but and 0.5, 0.5, 0.4. And if we just go up here real quick, that's gonna be ground. And that's gonna be fine also. Yeah, absolutely no shorts anywhere, no liquid damage, no nothing, just flashing on and off that I could see. So let's get this under a thermal camera. So we're gonna switch back to our camera here. And what I've done is I've just put this little connector on here just to test the board. This way you don't have to put it back into the computer. All right, so it's just this, you just plug a USB connector into the side here. And we're going to go under our thermal camera and see if we could spot any problems here. So let me get under the thermal camera here. And let me actually hook this back up because this fell off. All right, so we're under the camera here. And let me get my power supply. And let's see what happens. Let's move it up here, see if we see anything going on. This board looks pretty cold. I don't see anything happening down here. Absolutely nothing. Let's check the other side. Absolutely nothing. Yeah, I don't see anything. I was hoping for... Oh, we do have something. Is that just reflection right there? I think it's just reflection. Let's plug it in one more time. Oh, something flashed right there. Just for a split second. Oh, there we go. We have our ISL chip. Something did flash right there. It flashed again. I'm not too sure if that's normal. But something is flashing right there. Let's see, wait till it flashes again here. Right there. What is that? Let me get my finger on it. Let me get it into the microscope. It's this right here. This guy is flashing on and off. All right, we're back over to board view. And it was this device right here. UF115. What is that? Power regulator, I think. It's a voltage regulator. Now, the funny thing is, I didn't see a short on this, but I wonder if, I don't even know if flashing, the way it was flashing is actually normal or not. But what I'm going to do is I'm actually going to take it out to see if it actually stops flashing because it only takes 2 seconds. I just want to see if the voltage stops jumping. All right, let's take this out, see what happens. Get a better pair of tweezers. Those were terrible. All right, so let's plug the power back in and see what we have here. And look at that on the screen, 20 volts. And we are taking some amp draw here. It doesn't look like the normal amp draw, obviously, but this board might actually be booting. Oh, it just went back to 5 volts. Back up to 20. The board is still warm. Did I just heat something up? Now it's 20 volts, 0 amps, and climbing. Let me check the other port. Now this port is still pulsing. Okay, let me go back to the previous port. Now this one's pulsing. So it's something on the board that I'm heating up. So if I heat up, let me give you some heat. If I heat up heating up the board, that's all I'm doing. There, 20 volts. It's something, well, isn't that interesting? And now if I check the bottom one, 20 volts. All right, so I've put this chip back on here, but now I have a new problem, and I'll show you. Let me just put this adapter on, and I'll show you the new problem we have. So now if I put this adapter on, and let's plug into the bottom one here. Oh, now it's steady, but it does pulse once in a while, and it's taking 0 amps. If I go to the top one now, I got nothing. So this has changed. So before, it was 5 volts on both of these ports, and they were doing the exact same thing. They were both cycling. I'm wondering the entire time if I had a bad CD3217. But let's just check here. So this is the main input. So let's just check to see if we do have a short. So let's switch to board view. And let's take a look at what we're supposed to have there. I think it's 0.1. 0.1 on that side, 0.1, of course 0.1 at the bottom here too, right? Okay, we're in diode mode, and we're checking right here. And we got 0.1 voltage drop. This should be the same right here, 0.1. We check the bottom, 0. We have a dead short here, which is wild because we didn't have a dead short before. So maybe from me putting voltage on and on and off on this connector here, it went shorted. I don't know because this is different symptoms than when we had before. I didn't have a short before. So let's inject voltage here and we'll see what gets hot on the other side. All right, so let's see what we got here now. So I've just put a ground onto this terminal right here. And where we're going to be injecting voltage is any one of these, oops, I can get my finger there, any one of those 6 spots right here. Let me see if I can get to show you right there. Any one of these 6 spots I could inject voltage onto. Let me see if I can get it a little clearer here. It's a little better. So any one of those 6 spots I can inject voltage onto. Test points right here. 1.3 amps. As you can clearly see what's getting hot there. You can clearly see it. It's right beside the CD chip. So let's zoom in here a little. So this right here is the culprit right now. Now, mind you, this could still be the CD chip because I mean, if I take this out and I still have a short, it's probably my CD 3217 here that's messed up. Because if I go back to my board view, if we flip back to board view here, yeah, this also feeds into my CD32. So I could take this out and that's what we'll do. We'll take this out real quick. We'll check to see if we still have a short right here at this location. Because if I go back to the main camera and check at that location right now, I'm pretty sure we are shorted. So let's go into diode mode. And let's check just right at this cap right beside it here. Let's check. Let's check right here. And yeah, we are shorted right there also. Right, so let's take this component off. All right, so that's off. I'm going to put that aside in case that is not the issue. Now, if we come now in diode mode and check right here, let's see if our short is gone. So if we check right here, our short is gone. All right, we have a donor board in here. And let's just take this out. These tweezers are crap. I can't even pick this up. Okay. Let's just grab our other board. I'm just gonna put this here for now like that. I don't want this flying away. It must have been when I was messing around with this that this blew or went shorted because I don't understand. Like, unless this was the problem the entire time, right? We will find out. All right, let's just quickly check to make sure we don't have a short. Once again, on diode mode, red probe on ground. We're going to check right here. And we are shorted. What the hell? And we are not shorted because I'm an idiot. This is why you wait after you heat a board, because now if I check, it's at 0.07 and climbing, 0.08. This only calls, remember, this only calls for 0.1. If this called for like 0.5 voltage drop, it'd probably be already up to 0.4 and I wouldn't suspect a short. But when you have something on a power rail that calls for low resistance and you just heat the board, the minute you check right after, it's going to still look like a short and you'll be tasting your tail. So that was my fault there. I didn't wait long enough. All right, so I don't have any 9240 HIs right now, new chips. So we're going to steal this one off this board. And then we're going to reball it, and we should be good to go. Alright, this is a donor board, so I don't care what it looks like. Alright, I'm not too sure for whatever reason I didn't hit record. Maybe I didn't think it was going to work. But I replaced the ISL chip, and lo and behold, if I go up here, I actually tried to reflow the CD 3217 here. I thought that might have been the issue because I was adding heat to the board, and it would fix the issue momentarily. So now when I plug in 5 volts, 20 volts. So it's negotiating 20 volts on that. And if I switch and go to my bottom USB port here, 5 volts, and it's negotiating 20 volts. All right, we got this back under the main camera here, and look at this, we got good luck charm, little guy here, little booty shake. You can't beat that, right? Anyways, I don't see any reason this should not boot, um, because it looked pretty good. So let's give it a shot here. I see no reason this shouldn't boot. And there it is. Perfect. right? Let's just make sure it boots up all the way here. And there it goes. Okay. Well, this one was a very interesting one. I should have, actually, I'm glad I didn't decide to replace the CD chips. They're a bit of a pain to replace, and then you have to find one that's paired and all sorts of nonsense. And the only reason I decided to try the ISL is because the LDO voltages on the CDs were the exact same once I pulled the ISL chip. So once I pulled the ISL chip, the amp draw was steady at 5 volts. You guys saw that. And I said, you know what? It's something after the ISL or the ISL itself, because after I did that, the LDO stayed stable on both CD3217 chips. Well, that's another repair, and hope you enjoyed, and I'll catch you on the next video.